We start with the experiment number 4 to determine the radius of curvature of a given convex surface using a spirometer. We can also determine the radius of curvature of a concave surface and also the thickness of a watch glass using a spirometer. So these are 3 experiments which can do together, but let's only do the convex surface radius of curvature determination. Apparatus required is a watch glass and spirometer. And you have a plain glass plate or a plain glass slab. So you have to take a plain glass surface and a spirometer and a watch glass. The working formula for the convex surface radius of curvature is d square by 6h1 plus h1 by 2. R1 is the radius of curvature of convex surface. D square by 6h1 plus h1 by 2, where R1 is the radius of curvature of the convex surface and D is the average distance between any 2 legs of the spirometer. So I keep it over here. I tell you about the spirometer now. So I have just finished with the working formula, what we are going to do. Now this spirometer has a tripod stand and a metallic frame, and there is the central leg which has a movable screw. The screw moves under the nut. There is a linear scale which is a metallic scale which is attached perpendicularly to the space, and the circular scale moves over this linear scale. And then the edge of the linear scale will be coinciding with the division of the circular scale, which will determine initial or final, whatever. Now there are 3 outer legs which form the imprint of an equilateral triangle, the vertices of an equilateral triangle. That's why we need a plain glass plate. And if you put it on a plain paper, they will form the vertices of an equilateral triangle. Then this spirometer, why is it called a spirometer? The spirometer is used for determination of radius of curvature of a convex surface or a concave surface, or even the thickness of a watch glass. It can be determined by this. Since it is using the word radius of curvature of spherical surfaces, that's why the name is spirometer. Okay. Here, the pitch and release count are the 2 constants of the spirometer. It does have an error, but since we are again like a screw ball, we determine I difference F using circle of reference, then here we will not talk about the error in the spirometer. Okay. So in this, the tip of the central leg, this is central leg, the tip of the central leg must touch the convexity. So first what we do, we take a watch glass, we take this is the curved surface, and we put a small, in a pen boundary, we put a small area where the height can be of maximum height. Within that circle, we go on touching the tip of the central leg. It is a small area. It's in a pen we draw it, and then we go on touching it for every first observation, second observation, third. So within that boundary, we determine the maximum convexity height. So that has to be first placed. So you have a plain glass plate and you have a watch glass. You put it like this, and you have to gradually put the spirometer over there to find out I. And then you remove the curved surface and see how many times the I goes till you touch the plain glass plate. The final is noted on the plain glass surface. So initial is in the convexity, final is on the plain glass surface. Number of rotation is the number that the initial circular coincidences covered till the closing point, that is till the tip of the central leg touches the plain glass plate. So you know I, you know F, you know D, you know pitch and discount. So let's start with the pitch. Now the definitions are as usual, as you have written in your screw watch theory. It is the linear distance covered by the circular scale over the linear scale during 1 complete rotation of the circular scale. And in 10 complete rotations, you will need to be going the number of divisions you will count, and then in 1 complete rotations, the number of divisions you will count to determine the pitch. So what is pitch? In 1, that means the edge plus linear scale. The 0 first you have to make the 0, the 10th division of the linear scale should coincide with the 0 line of the circular scale. Find out, do it.
So what is least count? Least count is equivalent to pitch divided by number of divisions on the circular scale. That means 0.1 centimeter divided by 100 divisions. That is 0.001 centimeter. Least count in this case is 0.001 centimeter. If you would have a spirometer in which 1 centimeter is divided to 20 subdivisions, then pitch will be 1 by 20, that is 0.05 centimeter, and accordingly least count will be 0.05 centimeter divided by 100, that will be 0.0005 centimeter.
So the least count definition, mind you, in the theory you don't forget to write that it is in the least count definition. What is least count in a spirometer? If someone asks you, you say that the distance covered, the linear distance covered by a circular scale over the linear scale during one smallest division rotation. So in 100 division it goes 0.1. So in 1 division rotation it goes 0.1 by 100, that is 0.001, or 0.05 as ma'am said, 0.05 by 100 is 0.3005 cm. So we go over to our determination of imprint.
We take it on that paper, just suppose we
No, first I and F, determination of H. Determine H.
for determination of S, as we are going to push on a common surface, so that we will raise the screw little upward, so that the three legs will be in contact with the convex surface, and we will keep almost at the center. The screws should be kept almost at the center. That means the three legs should be equidistant from three sides. We have to check that while keeping that the three legs should be almost equidistant and the screw should be almost at the center. Now we will hold it tightly and rotate the disc and take care so that the legs will not be raised, and the disc, rotate the disc till the central screw touches the convex surface. We can check it doing again by inserting a small piece of paper. If it passes through the, we will insert a small piece of paper to see if it is passing through the screw or not. Now to check whether the central screw has touched the surface or not, we will insert the piece of paper. If it is being obstructed, if it is not passing through, that means the screw has touched the surface. That time we will take initial circular scale division, which is coinciding with this reference line. Here in this case, now 34. Now 34 is coinciding with reference line 34. So we will start with 34 and let us see how many complete rotations occur. 34 crossed once and it stopped at 14. Then again you will insert the paper and see paper gets obstructed. The initial circular scale division coinciding was 34. Now it stopped at 14 after undergoing one complete rotation. Complete rotation 1, FC is at 14. So difference will be, as ICSR is I is greater than F. So difference will be 34 minus 14,
that gives you 20. Then pitch into number of rotation, pitch is 0.1, number of rotation is 1. So 0.1 into 1 gives you 0.1. This is your pitch scale reading. Then extracircular scale division multiplied by least count, that is, this is your extracircular scale division 20. 20 multiplied by least count. 20 multiplied by 0.001 gives you 0.020. Okay? Then it will be 0.120. Add them, it will give 0.120. Again, repeat. Again, this pitch, these are the two constants, this will remain same. Only the initial will change around 10 divisions. So you can take again, suppose it is instead of 34, it is 36. Number of rotations 1. And then take the final will be more or less 14, 16. You can take it, suppose it is 60. It will not vary more than 1 to 2 divisions. But that doesn't mean you will not do it, you have to do it, find it out. So in this case again, you have the final, this initial is 36, the final is 16. So again we get a 20. So let's say it is 14. Let's say 14. So 36 minus 14. Doesn't mean, sometimes it will be repeated, okay? So it was again coming 20. I have just taken it on it. So 36 minus 14, it will give you 22. 36 minus 14 gives you 22. 22 multiplied by the least count will give you 0.022. So, and pitch scale reading is again 0.1. This is your pitch, this is your pitch, this is 1. So, pitch 0.1 into 1 gives you 0.1 into 1 is 0.1. And here the next reading is 0.022. So, next is 0.122. This way 0.120, 122, 121, 120. In this way you will have 10 such observations and then take the mean observation here. Okay? So, now here, the next is you have to take a plain paper and put the piece of plain paper. You put the imprint of this outer legs. They will fall into the vertices of an equilateral triangle. And then the equilateral triangle will have ABC triangle. So you will have you will have to measure for every figure. This is first figure, second figure, third figure. So every figure, equilateral triangle has equal sides. But still then, measure ABC triangle. The side AB, BC side, they more or less they are the same. But take the mean as D1. Similarly, for the next figure, take the next AB, BC here. D2 is the divided by 3. Sum of the three sides divided by 3. Take the average length of every figure. So the equilateral triangle. So D1, D2, D3 are the average distance between any two legs, outer legs for every figure. Then after getting these three averages, take the grand average, which is D is equal to D1 plus D2 plus D3 by 3. So that will be sufficient enough to calculate the average distance D between any two outer legs of the cylinder. So what is the distance, ma'am?
3.5.
3.5. So
1%, 2%.
this is 3.5. Next one. Again.
Next one, 3.6.
6.
Next, 3.5.
Okay. So, see, sometimes there is a difference. So, you have to, that is why you will take the mean of this D1, D2, D3 and take the grand average. Then, after that, you take this, use this formula. R1 is equal to D square by 6H1 plus H1 by 2. So, here, this is D, you have already found out D is the grand average. H1 is, we just found out that 0.220221, that mean of that height. That is initially you took the initial observation on the convex surface and then the final was on the glass plate. See how much time the initial went through till it reaches the glass plate. And so you have H1 and D and you calculate using this formula. You know, this formula, I just wanted to tell you. So there is a diagram over here. You may wonder. This is the convexity is here. This is the tip of the satellite touches the convexity. This is a part of a sphere. Now, it is this formula has come from this, that this length into this length is equal to h into 2r minus h. Capital R is the radius. So 2r minus h. So G jahan pe laga hai. This from here to here, this plane surface. This is the height that you are measuring h1. So from the convexity to this plane AB. From the convexity to this plane AB is h1. So h into 2r minus h is equal to a square. This is a quadrant. So from there the calculation comes as R is equal to L square, D square, this is L square by 6h plus, D square by 6h plus, L square, D square, it's a L square. So we have found out, this is for H1, convex surface. Now, suppose you are given to determine the radius of curvature of a concave surface. How do you do it? In that case, the initial reading will be taken on the glass plate, same table. Table 1 remains the same. But initial, you are taking it here. Initial was taken here. Convexity here. You will take the initial reading on the plane glass. Then you put the concavity, the maximum depression wherever it is, touch the tip of the central should touch the glass surface. And then final is in the concave surface. Okay. So initial is on the glass plate. final is in the concave surface. So then again H2 is determined. D is a constant for the instrument. So you know I'm using the formula d square by 6H2 plus H2 by 2 gives you the R2 concave. R2 concave. Let's go back to the theory where we had written for the concave surface as well as this is for the clockwise. This is your H1 which was determined. This was for the convex surface. Now concave surface, the screw tip is turned in one direction to make the tip of the central leg touch the plane glass plate. Initially is taken on the plane glass plate. Then final is taken on the concavity which is placed over the glass plate. Okay? And the circular scale division coinciding with the edge of the linear scale is determined as I. And then the screw head is turned enough to place the curved plate watch glass with its concavity upward over the plane glass plate. So the initial is restored back. Next screw head is turned till the tip of the central leg of the spirometer just touch the curved surface. So circular scale division coinciding with the edge of the linear scale will be giving you the final circular scale coincidence F. Then the number of rotations that I has covered is this N is recorded for the concave surface. Exactly the similar thing that you have recorded for the table 1. So H2 is determined the same way, but again the same formula, I difference F which is I greater than F which is I minus F and 100 plus I minus F for a clockwise rotations. Remember, and the circle of reference also stands the same here. Okay, and then the thickness of a watch glass, if it is asked, after determining R1 and R2, the next thickness of a watch glass is determined by using convex minus concave. Convex minus concave. So I have finished with this, and then it comes to precautions. The pitch and release count should be determined carefully. Number of observations large. Parallax to be avoided. What is the parallax? The initial when we are recording when it is coinciding with the line of the scale, the edge of the linear scale. Backlash error needs to be avoided by turning the screw head in the same direction. What is the backlash error? We just told you while determining pitch that it was the zero was coinciding with the zero line. It was given 10 upward rotations. Now, if it does not cover 10 rotations, 10 divisions, in 10 complete rotations, if it does not cover 10 divisions, then there is a backlash. Suppose it covers 9 divisions. It is due to the wear and tear. Okay? So, due to the loosening of the screw and the nut. So, the backlash error is avoided by turning the screw head always in the same direction. The tip of the central leg must touch the maximum convexity during the measurement of initial circular scale coincidence I. Final CSD, a circular scale division, should be taken on a glass plate for this convex surface. Since the concave surface is not for this experiment, we can just record this much precautions for the convex surface. But if you are given concave surface and watch glass, you can write about how I and F for concave surface should be determined carefully. Okay?